Last time we have seen if the q of x is equal to sine ax or cos ax, then how to find the particular integral of the given non-homogeneous linear differential equation of nth order with constant coefficient. And we have seen the theorems on this topic. Means if f of minus a square is not equal to 0, then 1 upon f of t square operate on cos ax is equal to cos ax upon f of minus a square. Similarly, we have seen the theorem if f of minus a square is not equal to 0, then 1 upon f of d square operate on sine ax is equal to sine ax upon f of minus a square. We have seen these two results of these two theorems. Now, if f of minus a square is 0, means if we substitute d square by minus a square in the denominator, then it gets vanished. This means d square plus a square is a factor of f of d. And then we want to see what is the effect of this factor 1 upon d square plus a square on sine ax and 1 upon d square plus a square on cos ax. First, we see 1 upon d square plus a square operate on sine ax, and we have seen that this is equal to minus x upon 2a into cos ax. We have seen this result. 1 upon d square plus a square operate on sine ax is equal to minus x upon 2a cos ax. And similarly, we are able to find 1 upon d square plus a square operate on cos ax. This is equal to x upon 2a sine ax. Now we want to see the examples based on this topic. Means examples of this type where q of x is sine ax or cos ax. Now, see the first example. Find the particular solution of the differential equation d cube plus 9d operate on y is equal to cos 3x. Now here, first as usual, we find the complementary function. For that purpose, consider the associated differential equation and then auxiliary equation and so on as usual. But in this example, they ask only to find the particular solution. Therefore, to find the particular solution, we know that yp is equal to 1 upon f of d operate on q of x. Here q of x is cos 3x and f of d is to be d cube plus 9d. Therefore, we write this 1 upon d cube plus 9d operate on cos 3x. This is equal to, we take d to be outside, we first operate 1 upon d and then d square plus 9. We know that 1 upon d is to be integration of this cos 3x dx. This is equal to 1 upon d square plus 9. The integration of cos 3x is sin 3x upon 3. 3 is constant, can be taken outside, and we operate 1 upon d square plus 9 on sin 3x. Here a is 3. If we substitute d square by minus a square, means if we substitute d square by minus a square, then denominators become 0. Therefore, in that case, we use the result 1 upon d square plus a square operate on sine ax. This is equal to minus x upon 2a cos ax. Using that result, this is 1 upon 3 minus x upon 2a is 3 into cos 3x. And after simplification, we obtain particular integral. This is equal to minus 1 upon 18 x cos 3x. In this example, they ask only the find the particular integral. Therefore, we find only particular integral. We are not interested in the general solution. Such type of short examples also there in the examination. Now we take this example 2. Solve the equation d cube plus d square plus d plus 1 operate on y is equal to sine 2x. Now here solve the equation means here we want to find both the complementary function and particular integral, and then taking the addition we obtain the general solution of the given differential equation. Now to find the complementary function, as usual, what we have to do, as usual, we have to take the associated homogeneous differential equation. From that, consider the auxiliary equation. Here the auxiliary equation is m cube plus m square plus m plus 1 is equal to 0. Now, from first two term, take m square common, we obtain m plus 1. From next take two, from two terms, we take 1 common, then in the bracket m plus 1, then m plus 1 common, we get m plus 1 into m square plus 1 is equal to 0. We factorize this m square plus 1 as to be m minus I and m plus I. Therefore, the values of m are minus 1, I minus I. From these roots of the auxiliary equation, we know that how to write the terms in the complementary function. Here yc is equal to c1 e to the power minus x plus c2 cos x plus c3 sin x. This is our complementary function. Now, to find the particular integral, yp is equal to 1 upon f of t operate on q of x. Here, the f of t has to be d cube plus d square plus d plus 1. Now we write this, we solve this by two methods. In f of d, we directly substitute wherever d square is there, we substitute d square by minus d. If d cube is there, we write it as to be d square into d and then substitute d square by minus a square, or you may write in terms of the factor d plus 1, d square plus 1, and in that you substitute d square by minus a square. I have shown this in both the methods. First, we consider yp is equal to 1 upon f of d operate on q of x is equal to 1 upon d cube plus d square plus d plus 9. Here we rearrange this term properly. We substitute d square by minus a square. Don't take derivative of minus square. We have to write this term first and then d means d square into d, and d square is minus 4 means minus 4d. Again here d square is minus 4 plus d plus 1 operate on this. After simplification, we are able to get this term in the form of minus 4 and plus 1 is minus 3, and minus 4d plus d is minus 3d, means we obtain this minus 3d minus 3 operate on this sine 2x. Now by the second method, we consider yp is equal to 1 upon d plus 1 into d square plus 1 operate on sine 2x. This is equal to 1 upon d plus 1. Substitute d square by minus a square, means minus 4 plus 1 sine 2x. This is minus 3 means minus 1 upon 3. 1 upon d plus 1 operate on sine 2x. We multiply this by d minus 1 and divide by d minus 1. We rearranging this. We get the next as to be minus 1 upon 3 d minus 1. This is d square minus 1 sine 2x. Then we operate this on sine 2x first. We substitute d square by minus a square, this minus 1 upon 3, d minus 1 as it is 1 upon minus 4 minus 1 into sine 2x. This is 1 upon minus 5. We have to take this constant outside. This becomes minus minus plus 1 upon 15 and operate d minus 1 on sine 2x. Derivative of sine 2x is 2 cos 2x minus 1 into sine 2x is sine 2x. This is our yp. And after simplifying this, we get this step. Here we obtain this minus 1 upon 3, 1 upon d plus 1 operate on sine 2x. From this, we come to this step. These are the two methods which you apply any one out of these two methods. Here we obtain yp is equal to 1 upon 15, 2 cos 2x minus sine 2x. And then from this, write the general solution. Y is equal to yc plus yp. We have find the yc already. This is c1 e to the power minus x plus c2 cos x plus c3 sin x plus 1 upon 15 into bracket 2 cos 2x minus sin 2x. This is the general solution of the given non-homogeneous differential equation in which the right hand side terms is of the type sin ax or cos ax. We see one more example. Take the next example. Solve the equation d square plus 4 operate on y is equal to cos 2x plus cos 4x. Again, we want to find the general solution. For that purpose, we first consider the associated homogeneous differential equation as to be d square plus 4 operate on y is equal to 0. From that, write the auxiliary equation m square plus 4 is equal to 0. We know that the factors of this is m minus 2i into m plus 2i. This is equal to 0. Means m is equal to 2i and minus 2i. This auxiliary equation have the complex and non-repeated roots. Therefore, we know that how to write the complementary function. Yc is equal to c1 cos 2x plus c2 sin 2x. This is our complementary function. Now to find the particular integral yp is equal to 1 upon f of d operate on q of x is 1 upon d square plus 4 operate on cos 2x plus cos 4x. Now we separate this term. This is equal to 1 upon d square plus 4 operate on cos 2x plus 1 upon d square plus 4 operate on cos 4x. Now, when we operate the first term, 1 upon d square plus 4 on cos 2x, we substitute d square by minus a square. For this term, a is 2, its square is 4. Therefore, minus a square is minus 4. And if we substitute this in the denominator, then denominator vanish, it becomes 0. Therefore, we use the our second theorem, means we use the result 1 upon d square plus a square operate on cos ax is equal to x upon 2a into sin ax. Using that result, the first term is x upon 2 into 2 into sine 2x, means x upon 4 sine 2x or x sine 2x upon 4. And in the second term, here a is 4, therefore its square is 16, minus a square is minus 16. If we substitute d square by minus 16, then denominator does not vanish. Therefore, we substitute it directly. Means for the second term, we get cos 4x upon minus 16 plus 4. These are the terms. Therefore, the final answer is yp is equal to x upon 4 sine 2x minus 1 upon 12 cos 4x. And then we write the general solution as to be yc plus yp. And the general solution is c1 cos 2x plus c2 sine 2x plus x upon 4 sine 2x minus 1 upon 12 cos 4x. This is the technique to solve such type of non-homogeneous differential equation. We see one more examples on this type. Consider this. Solve the equation e to the power 4 minus 1 operate on y is equal to 30 cos 2x. Now we have seen the so many examples in which the right hand side term contains of the type cos. You may take of the type sine, no matter. We have to use the corresponding reasons for that. Now here to find the general solution of this differential equation, again the same method. First find the complementary function and then find the particular integral. To find the complementary function, we consider the associated homogeneous differential equation. From that, write the auxiliary equation. Here, the auxiliary equation is m to the power 4 minus 1 is equal to 0. We first factorize it. M square minus 1, m square plus 1 is equal to 0. Again, we factorize it. M square minus 1 is m minus 1, m plus 1, and m square plus 1 is m minus I, m plus I. Means the total factors are what? M minus 1, m plus 1, m minus I, m plus I is equal to 0. Therefore, what are the values of m? 1, minus 1, I, and minus I. Therefore, the complementary function yc is equal to c1 e to the power x plus c2 e to the power minus x plus c3 cos x plus c4 sin x. We know this how to write the complementary function depend on the roots of the auxiliary equations. Now we want to find the particular integral. Yp is equal to 1 upon f of d operate on p of x. This is equal to 1 upon d square minus 1 into d square plus 1 operate on 30 cos 2x, take 30 outside, and we substitute d square by minus a square, here is 2. Therefore, we substitute d square by minus 4 and then denominator not vanish. We get this is 30 upon in the first bracket minus 4 minus 1 into minus 4 plus 1 cos 2x. After simplification, this is minus 5 into minus 3 is 15 and numerator is 30. Therefore, we obtain 2 cos 2x. This is yp. And then combining this complementary function and particular integral, we obtain the general solution is yc plus yp is equal to c1 e to the power x plus c2 e to the power minus x plus c3 cos x plus c4 sin x plus 2 cos 2x. We obtain this general solution of given differential equation. I hope this much example is to be sufficient on this topic. Now you take the examples for practice. These are the examples, exercise. You solve these examples. Usually you try the third example properly. Okay. Now we stop our today's lecture.